Now it's working. Yep. So we will see what we can do now. The first thing is how to build up a daisy chain. That should be well known, but of course there are some limits also, and we have to discuss these limits. And then there is the question, when do we need extraordinary solutions? In several cases in the praxis outside, we have found out that the normal daisy chain, what we are offering, is not enough, so it needed to do some extra. And then, of course, how can we solve these requirements? And then I will give you an overview with some drawings over the different variants which are possible, and on the end, some conclusion. So the first thing is, of course, the daisy chain solution. The question is how to create the daisy chain, the limits of the RS for the 485 bus, and of course the limits of the TA cables, because it's not the same from the bus and from the cables. Well, at first we have to see what's happening on the RS 485 bus system. As you know, a Modbus or backnet communication is using the RS485 bus system, and this requires, of course, a serial connection of the units. What does this mean now? There is somewhere a unit, a central unit, a PC, PLC, whatever, called master, and then we have several slaves afterwards. And then there is a master, and this master is, like in the music, is organizing what's happening on the bus. So at least he is taking care on the traffic of the bus. So the master is saying to the slaves what should happen. That was explained by Rickard, and I will not go more in deepness there. As you can see here on this photo, the master is this PLC unit in the switch cabinet connected to a PC, to a laptop, where the screen is used to show something what's happening on the system itself. So the PC or the laptop, whatever, is only a platform where you can see some things and the reactions of the, for instance, the actuators and the valves. So, but we have also to know where the limits of this bus are. The communication lines, they are limited in the extension, and the maximum length is depending at the transmission speed, at the cable cross section, and of course of the cable quality. That means the resistance and the capacity of these cables. And this maximum length here of the bus, of one bus line for 19,200 baud per second is around 1,200 meters. And baud per second means baud rate, that is the speed of transmission. It's yeah, at least it's the number of signs per second which are transported over the bus system. And then there is also a maximum number of units or nodes on the line. And on Modbus, it's 247 addresses what we can give. And for the backnet, it is only 127 pieces. And that makes also a little bit a difference. The last slave or node is practically the end of this communication line here. And it must be closed by a terminal resistor. And this terminal resistor is normally enclosed in the most of the slave units and can be activated or not. In our slider 160, for instance, you go into the app and then you can say, yes, it's the resistor is set or not set, for instance. But also on the begin of the line, there must be such a terminal resistor. And normally this is part of the master unit. So that is not our topic here. Our topic is practically this one. So we have clearly to think about the principle of the daisy chain connection. Daisy chain connection is not a TA unique naming of this one. Daisy chain is a more common word for this type of connections what we are using. So in the data sheet, you can read out that we are starting with the A cable, and then we are using the B cables between the actuators, and the C cable can be used for special purposes. The C cable, we will see a little bit later what we can do with. When we are using prefabricated cables, then it seems to be simple. And you are starting there with one cable and then going from one to the next, like on this photo. Here you can see it's a slider 160 only on a manifold. And you see the non-professional cables between our actuators that was a little bit untidy by some tests we did at this plant, and therefore the cables are not sorted in a correct way. But we can clearly see there is always the interconnection between the actuators. But now we have to think about the limits and some problems with these prefabricated cables. These cables are limiting the number of the actuators on one line. And there are three main points which are defining these limits. The first one is the maximum length of the cable. They are only 10 meters long. All three, only 10 meters long. The second one is the cable cross section, which is 0.35 square millimeter bare wire. And this is, of course, limiting the actuators by the power demand. And there is a table available, you have all seen it, I think, where you can see the power supply in DC or in AC voltage and the number of 160 or 500 actuators on one line. And the reason for that is that the limitation is given by the minimum available voltage on the end of the last unit. When you read the data sheet, then you will see there is noted 24 volt AC or DC, minus, in the data sheet is noted plus minus 15%. So theoretically, you could start with 15 plus and end up with 15 minus here. That would make it a little bit longer, but you should not do this because it's depending on the load. So at least here in this point, you must have 20.4 volts. So that is 24 minus this 15%. And it's important to know that the current which is taken by each actuator is, of course, increasing step by step from the end to the begin of the network, or no, sorry, not network, of the line. And then the resistance of the cables is reducing the voltage, of course. And then there is, of course, only the possibility to integrate the slider 160 and the slider 500 into these lines, because only these two types of actuators have practically the possibility of using these prefabricated cables. And then there is one fact, of course, which is, let me say, a little bit more unofficial. The cables are sometimes carrying problems, especially the new cables, which are relatively hard, and sometimes, or from time to time, they are jumping out, and then you don't have a contact, and then you are missing the next units there. So they are working on this problem. It's caused by the halogen-free cables and by the type of the connections. It should be solved, but you should know it. And if you can reduce the amount of plugins per motor or per actuator, then it would also increase, of course, the safety on the bus. So now, why do we need extraordinary solutions? We have a challenge for the practical applications, especially extra power supply. And why do we need a third wire in a two-wire communication system? That is a big question. In a real application, we can for sure say that we don't have only the 160 and slider 500 actuators. So the 500 slider is mounted on a TN50 modulator. So that is not a big system then when we have only TN50 valves there. So normally in a real plant, all valve sizes are mixed. And yeah, then we need, of course, the 160 up to the 1250 slider in one chain. And how can we solve this problem then? Of course, it's a question of the distances. And when the cable is only 10 meters long, then you know already where the problem is. If you have to go from one, when you have decentralized valves, for instance, and you have to go from one actuator to the next 10 meters, that is not a long distance. We can say if we have, for instance, a cooling ceiling, the distances, they are not so big, and perhaps you can take the straight way from one valve to the next, or some 2 or 3 are closed together, and then you have to step over to the next one and so on. Of course, when valves are mounted on a manifold, as we have seen before, then the problem is not so big, of course. So you have seen on the picture only short cables were used between the actuators. And yeah, you have in most cases you have to integrate also non-TA units into the communication line. So it's not only the bus line going from one slider to the next. Sometimes you have to integrate some, let me say, a fire damper or a lightning unit, whatever. It could be used on the same communication line, and therefore it is necessary to integrate also foreign units into one and the same communication line. Yeah, what's more? Of course, the first question is of how to integrate an additional power supply when the Dasy chain must cover more than the described amount of actuators. So that is the first thing what we can solve. That is relatively simple. So the easiest way is to use the same power supply unit and connect only the 2 power lines, brown and white, from the C cable. So that's simple. You can see it here. And then we take the brown one and the white one. So that is the power supply, the 24, the hot one, and the 0 of the power supply, and connect it with a C cable after a certain length of the line. So the data transmission is then still passing from the A to all the B cables and so on, and it's transporting the information from one actuator to the next, but we are feeding up after, let me say, 10 or yeah, what's ever described in the table, 10 or 15 pieces. We can feed in or boost or power boost, so to say, with the power supply. So in that case, you see that are the connections we are using. And on the other hand, it's important to know that all of these lines are interconnected. So here there is M, the mass. So that is the white one. All 3 cables, all 3 plugs here are interconnected. The A and the B is only from the left one to the right one, and the 24 voltage power supply is also interconnected to this C cable here. So you have to keep in mind that at least the first and the third plug, they are totally interconnected, and only the M and the L24 from the C cable is connected to these lines here. So it's important to know how this is working in practice, because then it's more easy to find out special solutions. So there is also a question, extra power supply. And therefore, again, we have to know what's happening on the cables and on the wires. What are they doing? And the A cable and the B cable, they are practically ident. The only difference is that the B cable has 2 plugs and the A cable has an open end here. And then we must be clear, 0 volt, or also called as a mass, a general mass in the system, is the white wire. This is this common mass potential. And the 24 volt AC is using the brown wire, and that is the power supply line. Both are used for power supply. Then we have the A and the B data. So there's the red and the black wire of the A cable. And that is used for data transmission. But be careful, this is not a standard. This is chosen by us to have this kind of colors. And then there is an important point, that is the shielding line. In that case, we are using a green wire, and it's not only a wire here. Over this long cable, there is also a shielding element, a cover, to avoid the disturbances in the data transmission. And the C cable, it's absolutely different. There is only the both power supply lines which are the same in this cable. So what's to do when we should use an extra power supply? Sometimes the elements are widespread out in the plant. Then we have to take, for instance, a second power supply. And then, of course, we have to respect the use of the different wires. It's important. The data lines, of course, they must be connected. And therefore, you can use 2 A cables here, or cut a B cable, whatever you do. So that would be the same. And then you are connecting the end and the begin of these parts. You can feed the power supply to the brown and white cable here. And then, of course, the data are transmitted here, and the rest is interconnected. And then we can have either the shield connected here, but we can also have a local, sorry, at first it's a wrong animation. Of course, we have to interconnect the mass potential here, so that the measuring is correct here. And of course, we can restart or start new shielding line here. The shield itself is on the beginning of the line, always to the ground. And please take care, grounding is different from mass potential. So it's not the same like this connection here. But this interconnection is giving the possibility that the data transport is correct. But the question of 3 wires is interesting. Why do we need a 3rd wire in a 2-wire communication system, where we say that A and B is the signal carrier, and they are organized in a special way to avoid the disturbances over the long distances. And disturbances can be generated by the wire itself or some other influences from outside. So the resistance, the capacity, and everything which is on a wire can influence a signal. And especially by the transportation of data, which are only, let me say, yes and no information. So it's a dual information only. We see, okay, this is what you can read in the internet also. You see the plus and the minus cable, they are carrying counter signals. So always the opposite of the one signal is covered by the other signal. And then the difference between these both is measured. But you can do a difference measuring in that case only when you have a common zero or mass potential for measuring. So it's not directly measured between these both signals. So it's measured from this plus to the ground or to the mass potential and this minus pole to the mass potential, because as you see, also the minus can go upwards here. And then the PC or the computer which is behind these things is calculating the difference of both signals, and then they can filter out if the difference, if there is not a minimum difference of x, then this is not a valid value, and then it will be skipped. So it's always using this counter signal, and this is the common mass potential as a measuring reference. So therefore, it is at least it's a two-wire communication, but the third wire is required. Normally, this is already given by the power supply. When you connect the power supply in the right way, then this is already done. So the white cable of the ABC is always carrying the mass for all our nodes on a line. Okay, so let's go on with the challenge. How to do a foreign cabling for this Dasy chain? How can we perform the connections? Because it's important that we have to do then some connections. And in that case, we have to see what's going or why to use external cabling. Of course, the limited cable lengths, as we have already noted before. And then especially the limited cable cross section. And therefore, it is mostly the power supply line which is influencing this and not the data transmission. And of course, when you are using external cabling, that is more flexible, and then you can place the valves and the actuators wherever it is necessary within a plant. And yeah, there is one solution which is relatively often used to use one cable for the communication line and a separated one for the power supply. So in that case, you can make the correct dimensioning for the communication line as well as for the power supply. Sometimes you can use cables, or cables are used with two thicker wires for the power supply and two thinner wires for the communications, but this is a solution which is relatively expensive, but it's there. And of course, we have from the beginning, we have to define or to clarify what's going on with the power supply. Will it be centralized or will it be decentralized? So both is possible. Okay, the choice of the bus cable is depending on these questions, what we have raised before, and therefore, of course, you can use either a shielded cable with a twisted pair for the A and B communication, or you use a three twisted wires plus shield. Mostly it's two twisted pairs, that's more easy, and one is used for the third line. So one twisted pair for the data transmission and one from the remaining twisted pair is used for the third line. So then you have a common mass through the whole system. And then regarding the sizing, we have at the moment 0.34 square millimeter. That's relatively common. Even better, 0.5, or for really long distances, 0.75 square millimeters when it's absolutely long, so when it's going to the end of this 1,200 meters. The bigger the cross section is and the lower the capacity of the cable, the better is the communication quality. So in the documentation of these cables, also the capacity and the resistance per 1 kilometer and so on is defined. And yeah, these twisted pairs, for instance, are reducing the capacity problems on a cable. But there is one point of clear to say: the decision of the cable type and all the details, this must be taken by the electrician or the control company or system integrator. We cannot and we are unable to do this. So we can give some of our knowledge, but please be aware. Don't say you have to take this cable or whatever. To give you some impressions, these both cables are both twisted pair cables and have a shielding on, but the difference of the shielding here, it's an aluminium layer which is over there, and here it's a copper mesh which is even either covered by tin or by silver, depending on the quality. So that is when you have really long distances and so on, then shielding is very, very important, because the cable is running through a plant, and when you have some problems from the mains or from some frequency converters and so on, the shield should keep this away from the signal cable. And as you see, there is already a third wire, but this is not the third wire we need. This is the connection cable for the shielding. Not all cables have these connection wires which is running in parallel. This is a photo of this cable with two different dimensions. You see 0.5 square millimeter here for power supply, and there you see already that the colors are different. And you see the yellow and white here is only 0.22 square millimeters twisted pair for communication. So on the markets, cable are available in the different qualities, but at least this is not our decision what cables they are taking. Yeah, the way of installation, of course, is very, very important. And again, the RS485 bus is based on a serial connection of the nodes. What does it mean? Again, you have practically the line, and then you have one slave after the next. And it is absolutely a no-go that you have somewhere a connection like this. They must be on one line, one after the next. This is absolutely forbidden to do something like this. Normally, you are starting from a controller or the computer interface, and then you are running through the system and taking one motor, for instance, for us, actuator, sorry, as we have. And then, of course, you can connect the nodes at any place on this cable. But there is one clear thing what we have to take in consideration. The maximum length between the connection point and the slave unit is maximum 1 meter. So that is that cannot be a 20-meter cable here. No, the bus line must go to the besides the actuator, for instance, and then you have to use the shortest cable, or 1 meter cable, for instance, to connect the slider 160 to this bus, to the main bus. And that you get also an overview of a practical installation. Here you see it's a little bit small, the picture, but here there is they have installed it really freely, the bus cable, and here is a connection box, and then you see here is the actuator, and the cable is wound around and directly connected to the actuator. The connection box in more detail is here. They are using relatively traditional connection materials. Also here you can see that this is the cable to the actuator, so to say the A cable, and then it's interconnected. And there are different possibilities available. For instance, such boxes where some connecting points are already there, or like this one, this is to screw, this is to plug in. The elements which are used here, they are similar to this one. This is the well-known Wago, and this is absolutely what they are using. It's in that case three connection points, pass in, pass out, and the middle one is for the connecting of the actuator. And then each point of the cable has its own connection point as it is described or defined in some countries. Today morning I have taken some extra pictures, and here you see already that this cable, this bus cable, is also a little bit different as we have seen before. But it was to give you also an impression of how this should look like. So this is the bus cable. I have removed it from my model railway. I'm using also a bus system there, but it's a little bit different type of bus. And here you see there is the red one. It's in that case it's not really red. It's entering the connection point, and here this is the red one out of an A cable. And here you see this is a cable which is not using a separated connection cable for the shielding. I have only twisted the mesh to one cable or yeah, looks like a wire, and then you can directly connect it, and the green one is the shielding cable from the A cable. So that it's important to know about these details so that you can get a little bit more feeling how electrical installations can be done. It's not so complicated. This is more traditional way to do this. Okay, now let's have a look on some of the variants of the solutions. I have done some examples. For instance, one which is used for slider 160-500 solution, but over long distances. There is another one where we have a mix of all sliders, and we have added a foreign unit within the Dasy chain. And let's start with the 160 and 500 in a long distance bus system. That is relatively simple. We can use the slider 160-500 where we have one A cable with 1 meter, so the shortest one on each actuator. So for calculation system, it's also simple because then you count the actuators and then you use the 1 meter A cable, and then the cabling, the rest of the cabling is out of our influence. The bus cable should be according to described details, what we have said before, and also the power supply must correspond to the earlier given descriptions. Of course, this is the minimum we can say. And then we have to decide if there is a separated supply line for the power supply, or we have a decentralized repowering of the systems. And please keep in mind, this mass potential must run through the complete system. So, yeah, when we have a solution with a centralized power supply, then it's relatively easy. You see, we have a common transformer, and then we have the two supply lines. I have used the same colors as we are using in the A cable, brown and white. And then the bus cable itself should be something between 0.34 and 0.5, depending on the lengths, of course. And then you see already here on the beginning, there is the master. The shielding is on the ground here, only one times, not somewhere else, to avoid a current flow, which can caused by the different potentials of the grounding. So only on the starting point there is the grounding, and then all the shieldings are on one line. And then the A cables are interconnected here, and everything is going well. And then again, please take care, the power supply cable, the cross section, so the dimension of this one must be calculated according to the voltage drop. So the first one is taking current, the second one also, and so on. And then there is a certain resistance over the length. And this, as I said before or explained before, is reducing our voltage down to this absolute minimum. And then either you can make this cable thicker, or you feed in locally and with an extra power supply. But take care, we are not allowed to exceed this 1 meter. So what can we do when we have a mix of the slider actuators at the long distance system? When we use the same power supply again, that makes it in the first moment a little bit more easy. And then we are using the bus cable like before, as you see here. And then, we are putting our actuators in line. So we are using the slider 160 as we have with 1 meter A cable here. And then we are using the same solution for the slider 1250, for instance, as a variant 1. We can use a short length of the cable, max 1 meter again, and we can connect A and B here. But we have to take care that we are connecting this one also to the common here, because when you see this one and you read the data sheet clearly, it's absolutely isolated from that part of the actuator. So if we are connecting the power supply here, then internally it's not connected. So we have to connect it outside, and it's important to take care of these things. Of course, then we are going on with the different actuators, and then there is a second variant of connections. As you have seen, or as we can see here, the actuator itself has 2 ports, A and A dash, and B and B dash, and then there is in the middle, there is the common connection. And then we can use, so using the bus cable is entering the actuator, connected here, and the outgoing bus cable is going there. And then it is not a big deal, because here we don't have 1 meter or something, because the bus cable is entering directly and going out there. So that is one of these things which could be done. Of course, also here we have to interconnect the mass potential so that we have the measuring the same measuring level for all on the same zero potential. So that is also a relatively simple variant of mixing the different actuators. So what can we do also? When we have a decentralized power supply, it's practically same as before, but you can already see here we have the second transformer somewhere, but we have running 1 bus cable through. And then it is the same like before. We can use variant 1 or variant 2. And then the only thing what we have to take care in that case, that is our third wire, what we need to interconnect the mass potential between the systems. It is practically the same like in an analog control system when you have a separated mass potential for the output, for the Y output of a 0 to 10 volt signal, and we have 3 wires on our actuator where we have to interconnect the mass potential of the power supply and the mass potential of the control output to get the actuator running. And of course, also there it is valid that we should not, no, we are not allowed to fall below the 20.4 volt on the end of the line. But this is not a typical thing for bus systems. This is also valid in standard systems when longer distances have to be overcome. Yeah, what can we do when we are mounted on a manifold? And in the manifold solution, normally you have centralized power supply. we can also mix our cables. So we can, for instance, start with a standard bus cable for the bigger ones, like this, and then on the last big one, then we can connect with the A and B cables the 160s and 500s. So that would be a relatively simple way. So we are starting from the master, going to the first one, that case to the second one, and then ending up in our standard cabling. So that is a simple thing what we can do, and there is no thing, there's nothing what is special except the mass potential connections. But we have to consider that the maximum amount is still according to the table, because we are coming from the same power supply. But in the beginning, we can feed in here the power supply with a thicker wire, and then we are starting with the A cable from the second actuator with the 0.34 square millimeter cross section. And normally that is it's not so common to have 16 or 17 actuators on one manifold. Well, before we are coming to an end of these things, there is the question of how can we integrate foreign units into the Dasy chain. And also there we have two variants. The variant number one is relatively simple. You have the Dasy chain. Then we are using an A cable, integrate a foreign unit, and therefore we have always to take care of the power supply of these units, because we don't know what's happening. So we can integrate it here in the bus itself, but it should always be an external power supply for this unit. We should never transport the power supply of this unit over our bus system. And then, of course, we have to take care on this common mass connection, as we have described before. And then, of course, with the second A cable, we are starting and going on with the Dasy chain. That is absolutely a possibility and a simple way. If we are integrating external things here, you have only to know the master here is knowing, for instance, from the integration, the protocol for our actuators. In that case, the master must also carry the protocol for this external power supply, for this external unit. Sorry for that. And when the master is knowing both protocols, then of course the master can say, with the first protocol, it's asking for this and for that. Then using the other protocol for the next one, like the external unit, and then using our own protocol again and asking the next and the next actuator. So that is a simple thing which can run absolutely in parallel. It's not really complicated or extraordinary. So in bus systems, it's very often used. So one bus is running through actuators, shadowing, lighting, safety protections, whatever it could be. A lot of different informations are running on the same cables. The second variant, which can be used, is of course the same as we have done before, using only a short distance here to go to this and use only two lines here and make the connection here. So in that case, you are avoiding to go in and go out with the bus cable again. But yeah, that is only a variation of the things. The rest is practically ident. Especially when you are using these things, don't forget to use, in that case, with the cable, the common mass connection. It's absolutely important. Also there, the 1 meter, that is an absolute value, should never go above this. So on the end, let's have a short summing up of these informations. Don't forget, RS485 bus lines, they can be built up in several variants, of course. So you should be flexible in thinking. And in that cases where the prefabricated cables A and B are not long enough, or if the power demand of the units, so that mean at least it's the amount of the actuators which should be connected on one bus, you can choose different variants of installations. So we are flexible in the installation, and we can use the C cable for the external power boost if necessary. Yeah, we can separate the power supply line from the bus communication line. It's very often done. And we can, as we have seen before, combine our cabling variants in a different way. And of course, still, always, if you need extra functions like the hybrid mode, or to connect the the digital input, or to connect the temperature sensors, then you can do this independently of the bus connections. So it's not directly interconnected to make these things. In big systems, the hybrid mode can help to reduce the traffic on the bus, because, as you have seen, the bus itself is limited by the amount of nodes what we can integrate. And at Modbus, it is 247 units, for instance, and that is because of the protocol and the speed of transmission. So the higher the speed of transmission, the higher the risk that you are losing information. So when we can reduce the communications between the master and the slave units, then of course hybrid mode can help. And I have really often heard from the colleagues out in the praxis that they are really happy about the hybrid mode, because they can, in that case, they are using the 0 to 10 volt signal to move the actuator, and then they are using the bus system to get all the informations from the actuators back what we can provide them. And they can, for instance, change over between heating and cooling. That is relatively simple, because that is one signal which is going to all actuators. Change over from heating to cooling. And then still control is taken by the 0 to 10 volt, because control takes a lot of traffic on the bus. And especially when you have quick reacting systems like air handling units, then you need a quick reaction of the actuators, so that not the cold temperature, for instance, is going out from the air side of the air handling units. So that's important to know, and we have to respect the physics around these things, and therefore, yeah, we can have long lines, we can choose some things, and it's important that you know that we have different solutions. So in that case,